let's start today's session. Let's see, is it sharing now? There you go. I'm recording. All right. So at last, we're done with the data preparations. But those were data preparations for creating our own model or likelihood ratios. Um, Now, we will divert our path a bit and and look into the race neutral AI model, um, and how we can rebuild our data, uh, so that we can test how the race neutral model fares or responds to data that's purely for African Americans, right? So our data is purely African American major depression patients in all of us. This is part one. Okay, so just a recap. So last time we finalized our analysis data frame finally, um, and then we've learned how to really think about ways on how to reduce the dimensionality of the data. And Anne's Teach One um, explains that really well. So, and you will be doing those things later. Okay. Just a tip. I think it was Chatrini last week. She's not here. Who asked me what to do when the colonel dies. I gave an incomplete answer when I was with her. Um, so I told her just rerun all your codes from the start, from the checkpoint, but that's not complete. Okay, the complete answer is make sure that you have a big enough server, right? So increase your server size because your kernel dies. The main reason for that is your code is too big to run. Okay, so increase the server size, and after you increase the server size, you have to rerun from from your last data checkpoint. Okay, you will experience something like that later. So now our agenda will be to understand the race neutral AI model. And then we will break out into lab sessions, and will be um, helping me go around and answer questions during your lab sessions, and then we will rate and teach one, and I will prepare the next teach ones who are yeah I actually forgot who they are. Yeah, so teach one who are Jocelyn and Oluferani. But I think Oluferani has not been attending our class, so it would just be you, Jocelyn. I will also check um, your project topic. So, Jocelyn, you signed up for mirtazapine. Okay, yeah. Okay, so Jocelyn, you will remain later. So to understand the race neutral AI model, we need to find out if our data. Can I change my teach one day? Yeah, Kwanda, maybe you can also stay back later. We'll talk about that. Uh, yeah. Okay. Yeah. You signed up for Shop Wanda Floxicin. Okay. Yeah. I have something that I'm thinking of. Okay. Okay. The first thing that we need to do to understand the AI model is we need to find out if we have enough data to rerun the AI model. Okay, so artificial intelligence is just a more complex statistics model, right? So statistical model, they've been very complex and became really advanced. That they're their own thing. But at the end of it all, a statistical model requires data, uh, input data to come up with an output. Okay, so do we have enough input data for the AI model to really predict whether uh, our antidepressant will produce remission or will not produce remission? Okay, so we need to look into the AI model and check our own data. And if the data is available, then we're good. But if the data is not available, we need to find the data and plan for a way to include that in our data set. Okay. So that's our task for today. We will create a plan. So I will not be touching a lot of code right now. Okay. I will be doing like really research task. Okay. So first we need to understand um, what we call regression, particularly logistic regression. Okay, so logistic regression is one of the foundational algorithms that are very helpful for machine learning or AI. Okay, so logistic regression allows us to predict a one or a zero, a binary outcome. So why a binary outcome? This is according to ChatGPT, by the way. So, but I entered this question. It gave me a very um, easier to understand explanation that we can use compared to Wikipedia, right? So this is the Wikipedia page for logistic regression. Yeah, you can use that, but I think this is simpler for our purposes. Okay, so where is that video? Okay, so logistic regression outputs logarithmic odds. Okay, so the logarithmic odd of the probability of y equal to 1. Here, remission equals to 1. Remember, we have remission as our outcome variable, is equal to the natural logarithm of b, y equals 1, etc. etc. And it will result into this kind of equation, beta 0 plus beta 1 plus times x1 plus beta 2 times x2 plus beta 3 times x3 dot plus beta n times xn. Okay, betas, the first beta 0 is called the intercept. So it's the log odds or the effect when all other variables are absent. Okay, and then beta 1 is the coefficient of variable 1. Beta 2 is the coefficient of variable 2. Beta n is the coefficient of variable n. So variable 1 will be something that we are trying to to measure. What's the impact of, for example, age? What's the impact of age? What's the impact of having disease? What's the impact of having a previous antidepressant history? So these are variables. Okay, so the impact of a variable is a variable, whether it's present or absent, in a binary data, present or absent, one or zero, will be multiplied by the coefficient, which is the impact. Okay, so in order for us to really have enough data for a logistic regression or for an AI model that is using logistic regression, um, we need to know the coefficients, the variables, and the intercept. Okay, and once we have those, the coefficients, the variables, and the intercept, we can calculate the probability of y equal to 1. So the probability of having remission is this equation. So so how so what does how do we get these data? The coefficients and the variables, and then we can just like plug in, create a function in Python to calculate once we know the coefficients and the variables. Okay. So in your, not this one, I don't need that one, this one. Okay. In your Blackboard, okay, um, I put an additional link here, antidepressant AI data mapping file. You can click that. You will go to a view only sheet. Okay, mine is edit, but yours will be view only for now. You can download it, but I advise you not to download it until tomorrow. Um, so because we will be putting in additional data on it, and so the additional data will be available by tomorrow. Okay, and and originally the data, this file looks like this. Okay, okay, okay. Just mine. Okay, and then I will hide this. Okay, column and so originally the data set has these columns. This file has these columns. So antidepressant, C group, C type, code, coefficient, likelihood ratio, body system, class, short variable name. I don't know what C is. Um, Notes and description. Okay. What I did, what we will do is we will focus on our own antidepressant. So for me, my focus is amitriptyline for our demo. So I filtered it for amitriptyline. And then in order to map things, okay. I'm so sorry. That's my mom. Yeah, okay. All right. So so I added these columns in. That's why I bolded them because they were not in the original file. Okay. So and initially, what you will do on your own file is you will filter it to your antidepressant, and you will. This is my process. Okay, you can do your own process, but this works for me. Put in a question mark on all of the cells for all of these four columns. Our goal will be to make sure that all of these columns have a value. Okay. So one is the data available? Yes or no? If it's available, give me the column name. Okay. Otherwise, tell me what actions are needed and what are the relevant codes um, for the missing data column. Okay. My intention is I need to have letter O complete, column O complete, the data column, because I can easily create a dictionary inside of a dictionary inside of Python with data column as the key and coefficient, the coefficient here as our values. Okay, so let's go about it one by one. Okay, so the first thing I want to show you to for us to do is go to the variable names that we are confident that we know we have, right? We're confident that we know that we have. So here, for amitriptyline, uh, we have these ADRM 2SN, ADRM 3DR, ADRM 4DN. And it was just like an antidepressant, same but no remission, an antidepressant different but remission, had remission, an antidepressant different but no remission. So we do have that data, right? We do have that data. So I will put Y here for these three. Okay. So yeah, right? And in our data, let me just make sure that we have our code available. It's easier so that we can. In our data, we just called SN instead of ADRMSN, we called it SN, right? SN. We call DR as DR, and we call DN as DN. Okay. For amitriptyline, only these three variables are predictive of remission. Okay. Other antidepressants might have, we're missing SR, right? Might have SR. Okay. But at least we know that these things we have. So is there any further action needed? None on our end, right? None. And then code mapping, because I'll just put NA, okay? Because there's no mapping required because the, the data is already available, okay? Okay. The next thing is this, ager. Ager is age group, okay? Ager is age group, 13 to 19, 20 to 40, and 80 to 89, okay? We do have age groups, right? We do have age groups, but we cannot. I actually made a mistake here in the age groups. Um, let's just go to age groups. Okay, I'll show you why. What I mean. What I mean. Okay, let's just wait. So so we will start here. I think you can go to AA. Look at AA, right? In the C group. I don't know what it stands for, but all of these things that we are looking at are AA, right? Um, Let me just, where's that code? So it's still loading. Um, just wait. Hmm. Let me push it a bit. Open another one. Maybe this one. Yeah. It's taking time. Let me just scroll down and then let's see if it's something we can easily find out. Here you go. Age group 13 to 0 to 13, 13 to 19, 20 to 40. And do we have that? 0 to 13, right? 13 to 19, 20 to 40. I actually made a mistake here. Okay. Because we use, instead of 13 to 19, oh, there you go. Where is that? There you go. So instead of 0 to 13, 13 to 19, you see there's an overlap, right? 0 to 13 and 13 to 19. So when we were coding it, it should have been 0 to 12 and 13 to 19, right? 0 to 12 and 13 to 19. That means we created age group 14 to 19 instead of age group 13 to 19. So that means we have to recreate it. So the data is the data available now, right? The data column should be age 13 to 19, 13-19, age 13-19, right? What the action needed is recreate the age group columns, dummy variables. Okay? And then code mapping should be, yeah, I'll just put in age 13 to 19. Okay? But the other groups, 20 to 40, 20 to 40, 20, 20 to 40, and 80 to 89, 20 to 40, 80 to 89 are right, are correct. Okay. So these are actually yes. And then let's age 20 to 40, age 80 to 89. Let's see, correct, 80 to 89, right? And then there's none needed here. And then this is not applicable. This is my process. I suggest that you follow the same process, but you can come up with a more a process that suits you better. Um, okay. So aside from these AA AA groupings, right? Um, we also have AA here, right? AA here at the bottom. Okay. Gender F. Remember that we did create a female variable. So this is, yes, this exists. The data column is female. I believe it's female. This is already the disease data frame. Uh, let's just go female. There. So yeah, we created a female column. So this is called female. There's action needed is none, and no need for a code mapping. A. And the last two AAs for amitriptyline are here. Okay. And EPI 2 plus means EPI is episode, REM is remission. Remember we counted the number of episodes and the number of remissions, right? So we do have a count. We do have a count. We do have a count, but it's not enough, right? We have to convert the count into dummy variables again. We wanted to convert for this to work. For this to work, episode must be a dummy variable of 2 or greater, and then remissions will be a dummy variable of 2 or greater. Okay. So this is no. So what's the data column? Um, we will design a data dictionary on the spot. Okay, let's just say epi 2 plus, P for epi 2 plus, episode 2 plus. Okay, and then remission will be remission 2 plus. Okay, it's just my preference to use these. Okay, um, and then again, action needed will be change episode count. Sorry, episode count to dummy variables. And then this one is change remission count to dummy variables. As you can see from our AI definition, we wanted X, the variables, to be presence or absent. Presence or absence. Having a continuous variable, which is a count, a number, a continuous variable, is not present or absent. We want to convert number of episodes into dummy variables that will just give us 1 or 0, 1 or 0. Okay. And then finally, for the code mapping, we will code map it to episode num. Where's the episode number? Num episodes. Num episodes. Num episodes as dummy variable epi. And then this one is num remissions as dummy variable. Okay. And then the last thing that I wanted you to look into before we look into these other things that we don't know is the intercept. Okay, at the very bottom. I think it's always at the bottom, or you can just filter here and then just call intercept, right? Intercept. So the data available is no. We don't have an intercept, right? let's call let we what column we will we create. We'll create an intercept column, or maybe I don't want to capitalize my data variables. Okay. So what's the action needed? There's none. Um, there's no column of this name. So my action needed will be create a column for intercept, or maybe create data for the intercept, right? Intercept when calculating AI outcomes. Because my plan is to create a function that will just calculate the AI outcomes once I have the list of all the columns and the list of all columns, and then intercept um, data. Okay. I will select all again. And I will go through your question later, Lemis. Okay. 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 So we've run out of columns that we know what to do with. Okay. The next columns that we will be interested in are the column group DXO. Sometimes you will see a DXI. Okay. DX just stands for diagnosis. Okay. And these column names, these um, codes were generated using ICD-9 codes. Okay, ICD-9 codes, and these are the ICD-9 codes for them. Okay, and these are the descriptions for those codes. I will um, expand these for now, okay. And then yeah, that works. That works. And then for the view, yeah, freeze bins. I will just freeze bin here, maybe. Yeah. Oops. There you go. Freeze bins. Freeze, unfreeze bins, and then another one. Freeze bins again. Okay, there you go. That will work. That will work. Okay. So diagnoses. Diagnoses are the same as conditions. Um, all of these will be no. Right? We don't have these data. We do have diseases, but our diseases were coded in SNOMED. They were not coded in ICD-9. Okay, so all of these will be no. Sorry. And so here, all of them will be no. So how do we find out about the data column? For these, our actions will be to retrieve um, diagnosis data, right? We need to retrieve diagnosis data, and we will come back to what we have learned during our first week, which is how do we create concept codes. So back here, back in all of us, we'll go to create a data set. Just click that. Okay. Um, we won't be doing the concept sets right now. We won't be doing the concept sets right now. We're just designing what we want to do. Okay. And then we will do them at the same time next week. No, after the spring break. Okay. I click on this. select concept sets. Okay. And diagnoses are the same as conditions. Okay. Okay. So as you can see, our vocabulary is SNOMED, but there's an option here that will change diagnosis codes into ICD-9 or ICD-10. Okay. So we can click that. Okay. You can click that, and then one by one we look into the codes that we want. Okay. Instead of getting the data column, I will go to the code mapping first. Okay. I'll go to the code mapping first. And then here in all of us, I will type this code 311. So 311. Okay. So now 311 says depressive disorder not elsewhere classified. We validate that. We validate that with our data. Usually you will do alt tab, but I won't. I'll just do this for now. Yeah, it is roughly the same thing here, right? So the ICD-9 code is, the code mapping is the same 311. Sorry, 311. Okay. And let's see how that imports. Okay, 311. If I click on that and then finish and review, okay, save concept set, create a new one, DX codes. I will DX codes, and then I create a data set just for example. So African Americans, DX codes, and let me preview the table. We are supposed to get the SNOMED code, download all the people with that diagnosis, right? But now we have, yeah, download all the people with that diagnosis, and we can create the SNOMED code. We can create the SNOMED code here. Okay. Okay, let's go back. And we have to do that for everything. You have to do that for everything. I won't bore you. I will create this for amitriptyline, and you will have everything ready. So now that we have a code mapping, the data column will be DX, and then like 311, right? But I will make our thing make it easier for us. Like I will just put it as dummy variable for diagnosis, right? And it will be the same for everything. Okay. And I will just make sure that I have the right code mapping here. Okay. Okay. Now CPT. CPT is a code for procedures. Okay. It's not the code that again all of us uses. The research was done probably a while back or using data that was coded in CPT. So again, we'll go to dataset, select concept sets, and it will be procedures here, procedure. Okay. So this will be procedure. Again, we do not have these data available. I'll put n here. I'll put dummy variable or procedure. The action will be retrieve procedure data. Retrieve procedure data. Okay. And how do we get the code? Again, when you go to procedures, most of the procedures are still in Snowman. But there is, again, a toggle here. We can toggle, and it will be an ICD-9, ICD-10, and CPT. Okay, clinical procedures. I forgot the number of what T stands for. Um, okay, so now I'll just put in this 90805. Okay, individual psychotherapy, right? I think that sounds correct. Let's see. Let's validate individual psychotherapy, modifying and supportive, and yeah. So I'll just put that uh, as the mapping code 90805. Okay. So far, so good, right? We use CPT, we use um, ICD. Okay. Okay. Finally, last two things. We see these gen. Therefore, RX is our drugs, right? Drugs RX. But their codes are in gen. Okay. And again, the codes in all of us are not in gen. They're in RX norm. Yeah. So RX norm or ATC. Yeah. I'm more familiar with RX norm. Yeah. RX norm or ATC or some other coding standard, but they don't use gen, right? So here we need, it's a bit more tedious. Okay. Again, for all of these gen, we don't have the data. We don't have medication data. So the data column will be the dummy variable for medication. Action needed will be retrieve medication data. So, and the mapping is a bit more different. Okay. So what we will do here is select this, right? Select that, and in all of us, put that as a search criteria. Okay. Search criteria, and find out that the actual RX norm code is 704, right? So we put that as the code mapping, 704. Okay. And we'll do that for the rest of the medications. I won't bore you with it. The last two things are this one. They're ICD-9. They're ICD-9, but and they're like routine gynecological examination and screening mammogram, and they're ICD-9. You would think that they were, well, I thought that they will be procedures, but they're not in the procedures. So ICD-9, the V codes are actually in conditions. Okay. So I select these ICD-9, And then I think I, s- I also was not able to select V72. If I go to V72, it does not return anything. Oh, it does. It does now. Okay, it does now. So routine gynecological exam. So you have to select the exact thing, right? That is described here. Okay, because there's a lot of V72, V72.8, so it's really V72.31 is what we're looking for. So that's the mapping. Sorry, that's the mapping. Why is there a space? Okay, and then you'll do the same thing for this one, V76, V76. Let's see if the magic still works. Okay, it's V76. It should be other screening mammogram. So V76 other screening mammogram, V76, I think 1.12. This one, other screening mammogram, is V76.12. So that will be our mapping. And then this will be retrieve, the column will be dummy variable for the diagnosis because it's not a procedure, even if it sounds like it. And of course, we have to retrieve diagnosis data for this one. And that will be, um, we will fill all of these out for all of your uh, medications. I would suggest that some of you start it early. For example, whoever has citalopram, you have a lot. You have a lot. Whoever has, I think doxepin is the other one. You also have a lot. Oh no, doxepin is good. Yeah, it's not. It's not you. Citalopram was the one that I found that's really long. Yeah. Okay. I will be doing data for amitriptyline and anything that is applicable to others. For example, these will be applicable to others. I will put that as well, so you won't have to change them too. Um, so that's it for mapping. Okay, we have to create a mapping. We have to create all of the new columns. So for example, uh, so that we can replicate the logistic regression function of the AI. Okay. Let me now, I will stop recording